Simplify fractions. Every fraction can be written in infinitely many equivalent forms. For example, some equivalent forms of, say for example, we have a fraction, any fraction that we want. So we will be starting with a very simple fraction, say 3 over 4. That's our first fraction. This fraction we have seen before that we can get equivalent fractions. So this fraction, if we multiply the top and the bottom value by 1, we would end up with 3/4. If we multiply the top and the bottom value by 2, we would end up with 6 over 8. If we had multiplied this by 3, we would end up with 9 over 12. If we had multiplied the top and the bottom value by 4, we end up with 3 times 4, 12, 4 times 4, 16. If we had multiplied the top and the bottom value by 5, we'd end up here with 15 and 20. In other words, these are all equivalent fractions. The same way how we can go this way, we can go this way. Okay? So that's how we get equivalent fractions. And that could go on forever. So when we go from this point to this lowest point, then we have we have the fraction in its simplest form. So let's write this note. A fraction is in simplest form or lowest forms, some people call it terms, when the numerator and denominator have no common factors other than 1. That's what it means. So we have to simplify fractions. So let's take a few examples now. The thing says, are the fractions in its simplest form? So are the fractions in its simplest form? This will be the first approach. So I'm going to put some examples, and I have 5 over 7. Is that in the simplest form? Yes, because they don't have anything common. Okay, since the in this case here we can say that since only the common factor of the numerator and the denominator is 1, the fraction is in the simplest form. The top and the bottom value have no other common factor other than 1. Okay, so this, yes. If we have now here 20 over 25, is that in the simplest form? The answer is no. Why? Because the numerator and denominator have a common factor of what? Yes, common factor of, so this is no, common factor of 5. So they do have something in common other than 1. Okay, so that's what we mean by that. So simplify a fraction. So how do we simplify a fraction? So let's simplify this one here, since this is not in the simplest form. So we can take here 20 over 25, and as we go along, you will learn to be able to do this much faster. 20 is actually what? But since we know that it has a common factor of 5, we can say that it is 5 times 4. 25 is 5 times 5. Okay, so what do they have in common? At least 1 5 that could cancel with each other, and that will give us 4 over 5. This is in its simplest form. We had this which could be reduced, so we reduce it this way. If for some chance you don't see the 5 here, but you could break down the 20 to smaller numbers, go ahead, nothing is wrong with that. So let's see how we would do that. We know that 2 times 5 will give us 10, times 2 will give us 20. We know that 25 will give us 5 times 5. If that is the way you see it, that's not a problem. Can we cancel any numbers? Yes. Cancel, cancel. What did we end up with now? We still end up with 2 times 2, which is 4, and 5 will give us 4/5. So we end up with the same solution. Okay? So let's try a few more examples. C. Simplify. Remember, in this case, I only simplify because we did know that this was in its simplest form. So we're going to simplify the fraction. What fraction is it? We're going to say 8/12. So we do the same concept. We try to get smallest numbers that you can work with. 2 times 2 times 2 will give us 8. 2 times 2, 4 times 2 give us 8. 2 times 2 will give me 4, times 3 will give me 12. So therefore, oops, I almost drop out of the screen. Cancelling out, notice what I said. 8 is actually 2 times 2 times 2. 12 is 2 times 2 times 3. They could cancel out the 2's, and that will give us equals to 2/3. Why? Because this 2 cancel with this 2, this cancel with this. Okay? And if you did not see it this way, can we do it the next way? If we use the number 4, can we use that? Let's see. Well, if we are seeing the number 4, we would say 4 times 8 will give, no, 4 times 2 will give us 8, and 4 times 3 will give us 12. So therefore the 4's cancel, giving us 2/3, and so the answer is still the same. So whichever approach you want to use, that will work also. There's nothing wrong with that. Okay? Now, if we have numbers, for example, we say, let me put here as D. We're going to put here D. We're going to use the number 9/27. Okay? Now we're going to cancel this. We know that we could expand this out, and this is 9. 27 is 3 times 9. Now, when we cancel this out, this is 1 and this is 1. This now gives us 1 stays at the top, and 3 times 1, that gives us 3, which is 1/3. Do not do the mistake that many people tend to do. When they cancel out here, they put a 0. That's not what happens. What happens here is that you have said 9 into 9, 1. 9 into 9, 1. So you end up with that. And so 1 and 3 times 1, 3. So that's how we get that value whenever we simplify fractions. Okay? Now, can we simplify a fraction which is bigger at the top compared to the value at the bottom? Yes. So let's try an example like that. Consider that we have a fraction, say, use black, E. If I have here 80 over, say, 25. Okay? When we divide this out, when we reduce it by two smallest numbers, we can see that there's a common value of 5. So we say 5 times what will give us 80? 1, 3, 6. Okay? And 5 times 5 will give us 25. So when we cancel the 5's here, this becomes 1, this becomes 1, and 1 times 16 is 16 for 5. These are still equivalent fractions. So the top value does not mean that because you cancel means that the bottom value will become a smaller number. It doesn't happen that way. Okay? You just cancel following the rules and you should be okay. Now, we have been doing positive values. What happens then whenever we have a negative value? Well, let's see. We have negative 20/25. Alright? Well, the negative here has nothing to do with our cancellation. So therefore this, let me put the negative here, and we put a line at the front, and 20 is 4 times 5, 25 is 5 times 5. This now gives me, well, when you cancel out the 5's, this goes away, this goes away, and that leaves us with 4/5. But that hasn't finished yet, because this negative will come here, and we keep that negative in front of the fraction. And that's how we reduce or simplify negative fractions.